All right, welcome everybody at the Swarm Fundamentals workshop. My name is Rinke. I am working with the Swarm team on a daily basis as product owner. And together with me, I have Janos. Janos, are you here?
Yeah. Hello. Hi,
Hi.
everyone.
You want to introduce yourself?
Well, I'm a developer at the Swarm team, so working on the new B implementation of the Swarm client. So mainly focusing on releasing this product that can be well widely used and yeah. To streamline the development of it.
All right. So, as I said, we're really happy that you are all here. And the workshop of today will be about Swarm fundamentals, meaning that we will first talk about the vision of the Swarm projects, like why are we building this and why do we need something like Swarm? And secondly, you will all have the possibility to work with the Swarm nodes. Janos mostly will be helping there and will guide you through the basic operations of the Swarm nodes, downloading it, starting it up, and interacting with our APIs. And if time allows, we're also going to upload a website and we're going to use the BSS, the messaging protocol of Swarm. Um, yeah, I see here Dixon from Tokyo. Great, welcome here. Thanks for introducing yourself. If other people want to introduce, feel free to use the chat function for that. Um, some rules of engagement during this workshop. We want this workshop to be as interactive as possible, meaning that at any time you can, I think, put up your hand. I don't have it myself, but if you are a participant, you can raise your hand. And if we see that, we can give you the microphone so you can talk. Also, we have the chat function and we have a Q&A. As a request, if you have a particular question, to use the Q&A and not the chat, because the Q&A will be easily able to parse and answer on that. It's easier for us. Some more questions, things? No? Okay, then I will share my screen and open the presentation. Are you guys seeing this? No? Present, not here. Should present from the beginning. This is the wrong presentation. This one. All right. Janos, can I have feedback from you? Are you seeing my screen?
Yes, I can.
All right, that means everything is correct. All right, so the B fundamentals workshop. As I said, the workshop is grossly divided in two parts. First part is about the vision, and we look at the vision of the Swarm project from two angles. One is what are the problems with the current architecture stack of the internet, and the second one is what are the opportunities if we would consider a different architecture like Swarm. The second part, we're going to talk about Swarm. This will be much more practical, but basically we're going to talk about what is Swarm in a nutshell. After that, you have the opportunity to download, install, and run Swarm. And after that, we're going more in detail about what is Swarm, and we'll talk about the distributed immutable store of chunks, all the protocols that basically make up the Swarm network. And then, as I said, we're going to see if we have time to launch a website and interact with Swarm using BSS. All right, let's get started. So the problems. Well, I have a whole bunch of problems, which is currently happening in our society. We have polarization, manipulation of electorate, rise of populism, the attention farming, overconsumption, failure to take collective active on climate change, living in bubbles, surveillance, social isolation, fake news, increasing wealth gap, demise of the free speech, rise of new institutions more powerful than governments, managed by profit-oriented molochs, and increasing xenophobia. So this is just a handful of I would say, problems which we are currently facing in our society, and I don't think any generation ever lived without problems. These problems which I enumerate here right now, however, they have something in common, and of course they are organized by many different factors which is currently playing in our society. But we believe that at least part of these problems is due actually to how the internet was being built up from the grounds, not the absolute grounds, which is the networking layer, the TCP IP, is actually pretty decentralized and open for everybody. But the layer above that, that's, if I go to my next slides, is basically well, I call in this slide the fundamental internet architecture, which is the client server architecture, is I believe that this is at least one explanation of all the problems which we are currently seeing, which I just enlisted. This is as such. The internet is built, as I already mentioned, on the TCP IP layer. And this is a layer which basically does nothing more than routing packages of information from point A to point B. I can send a message to anywhere around the world, and this fact that I can send a message is used by the client server architecture, basically to host websites or applications. As you can see in the diagram here, the server is hosting the data and the application, and the client, this is for example you, if you go with your browser, you visit google.com, you make a request to the server owned and managed by Google for the main page of google.com. And the server answers you with a response, which is the HTML and the JavaScript usually containing this web page, right? So this is the fundamental internet architecture. Well, nothing wrong with that inherently. If there are many servers and many clients around the world, and there's somewhat of a balance between those, this architecture is not wrong. And I'm also not claiming that it is wrong inherently. I'm just claiming that right now it's the only architecture which is built on top of the TCP IP, or maybe not only, but the most prominent. Actually, in the early stages of the internet, the web looked about this. You had a lot of clients, a lot of servers, and there was a balance between the two. So in the nascence of the web, and this is what we call Web 0, you used to have many small and independent websites. Those websites were usually self-hosted. So as an example, I would make my own homepage, rinke.com or rinke.nl, because I'm from the Netherlands. And on this website, which is my own server, it could be even my computer, or it could be just, I don't know, Raspberry Pi or some similar from the 1970s. But on this computer, I really had physically, I had my data hosted there, and this server would respond to questions from clients. So it's self-hosted, and because of this, because I'm hosting the server myself, any data which is on this server and also the application itself is owned by me, right? Because I own the hardware, I own the application and the data. Often they were hobby projects because the internet was really something new at the time. There was not really a business model, or they were just geeks using cool new technology. One problem of the Web 1 is that it couldn't cope with significant increase of demand. And that's what actually we were seeing that time as well. You had small websites like Rinke.nl. Well, in normal times, I would probably have 1 or 2 visitors a day, not much more. But disaster struck when, for example, Rinke.nl was linked from another much more popular website. Let's say at the time there was another website which was indexing the most famous people from the Netherlands. I was never linked on this website, but suddenly I was linked on this website, and what's more, I was linked on the top of the page. I was featured because I was an uprising star in the Netherlands. That's an example. Well, what would happen at that moment with my website is that a lot of people would visit my website, and basically my small Raspberry Pi crashed, and because it cannot cope with significant demands, right? That's actually a very complex problem to solve by myself. And whereas I would be able to, make and hack my website together, I probably wouldn't have the time or the resources or the understanding to actually make a scalable web server. I probably wouldn't even have the money to buy all the hardware needed for that, right? All right. So that's what one. I don't know, Janos, do you have something to add to this story?
Well, you got all things nicely lined up here, so I basically well, agree with you.
All right. Cool. Then we go to some examples, and I just found this online because, of course, I wasn't even born when all of this happened. But I found an example of NSCA Mosaic, one of the first web browsers. Yeah. And then there's an example of an email terminal from 1971. And you see really people are playing here. So, oh, I totally did this. What is this? It is like an electronic version of the mail. It's quite cool to see this, I think. All right, but the crucial mention here is that if you analyze how Web 1 was built and how people were using it, it was doomed to change. And we can reason about it, of course, in hindsight very easily. And that's what we're going to do right now. So one reason it had to change was because of economies of scale. So I don't know if everybody knows this term. If you did a major in economy, probably you do. But in basics, what it means, the bigger, the better, or the bigger, the more profit you can make of it. And there are two factors that explain this economies of scale. One is the cost to operate a website grows less than linear with the amount of users. It's a complex sentence, but we have an example for this. So this is MySpace, early social websites for social media. And if you think about it, the cost to operate the website grows less than linear with the amount of users. What I mean is that the cost of hosting 1,000 MySpace websites or MySpace pages, I should actually say, is less than hosting 1,000 personal websites, right? So let's say 1,000 pages on MySpace, maybe the cost for MySpace to make one additional page, maybe 5 cents. I'm just making up an example here. Whereas if I would make a page similar like this, well, first of all, I would probably have to do much more effort into making this. I need to buy the hardware. I need to figure out how I'm going to design it. I need to do all kinds of difficult things, so the hosting and the effort. But also the cost to host it. MySpace can just host very, I don't know, just hardware suitable to have 1,000 websites. But you can imagine that buying one very big hard drive of 1 terabyte doesn't cost as much as 1,000 USB sticks of 1 gigabyte, right? So this is also an example of economies of scale. Yeah. So that's one factor which made the Web 1 doomed to change. Second factor is very simple. Bigger websites with more users are just more fun, right? If I have one website, and I think MySpace actually is an example of this, I can browse through all the pages. It's very easy. And because of this, it's more fun to have one website with 1,000 profiles versus 1,000 profiles scattered around websites, and I cannot link them, or they have all different layout or whatever, right? But it's not economies of scale actually, but I mean, it kind of is. Yeah. So example is Wikipedia. Wikipedia could have never been made by a single person. And this, by the way, is the homepage of Wikipedia when Wikipedia started. Yeah. So I made some animations because these powers actually make servers to go down, right? Because maybe some of those servers, they basically bundle together. All right, so remember the fundamental architecture of the internet like this. Because the server is hosting the data and application, what we're seeing, oh, yep, okay, is the emergence of data silos because of this. In the early space, in the early times of the internet, it was not that much, not as we have right now, but it definitely was more of a centralization of the data and the application towards the few servers or like the handful of servers which survived. So the other one, why the Web 1 was doomed to change is the search for a business model. You have here this very nice animation. This was actually the first advertisement which appeared on the web. Yep. So the industry, the internet industry, because it was something new, people saw the opportunities. But at the same time, they were really looking for, okay, what business model can we make of this? There were many people which were telling that you know, the internet is so great, you can send a message to everybody around the world in less than a second. But of course, to sustain such an infrastructure, it's important that a business model needed to emerge, to expand it. So in the beginning, there actually were quite a lot of investments also in internet businesses. But truth is that most of them didn't know how to make business, right? And the industry eventually settled on ads as a main business model. Well, you can think about that what you want, but what I personally think is that advertisement on the internet isn't the only feasible business model. It is definitely not the only business model. Like maybe some companies are, you know, will be doing very good with advertisements as a business model, but some not. What we are seeing right now is that basically most of the internet businesses are having advertisements as their business model, and this creates all kind of strange things. Yeah, but we are not there yet. We're still at Web 1. So the industry eventually settled on ads as a main business model, and ads are more effective the more you know about your users, right? Yep. All right. So this is a diagram of the dot-com bubble, which was in the early 2000s, and it kind of reflects, I think, the hope of people of being able to have a very good business model on top of all this data of the users, on top of all the opportunities which the web allowed. But as you probably know, this was merely hope, and actually people found out that at this point, at least, no real business could be made, and that's why the prices of the stock market of internet businesses crashed. All right, but of course, people invested in those companies. It was, you know, real money at this point was invested. So there was a real pressure of actually making the industry more efficient, of making the industry profitable. And one of the ways how it was done is that many smaller internet companies were acquired by bigger ones. So this is also, of course, related to economies of scale, because if you have many small internet businesses and you manage them under one hood, you're able to have lower infrastructure costs. And on top of that, you have more possibilities for earning revenue, like doing an analysis of your users and advertisements. Basically what happens. Yeah. So actually here is interesting to know that actually at that point in the early 2000s, many small internet businesses who were startups, they didn't even have a business model in mind. Just the only thing what they wanted, the end goal for them was to start up a business, do something cool, get a lot of users, and be bought by Google or Facebook or one of the other big businesses. Yeah. So just to put it in perspective, how people were thinking. And just this is an example of Google's new data center in the Netherlands. And for you, it's, I mean, obviously it's something different than a server which is just self-hosted to host my own personal website. Okay. And disclaimer here, of course, I'm losing a lot of nuance in this story, right? There's many more points to look at the history of the web. There's many more ways to explain the ways how things have been changing. This is just one of those. And actually, later on, we're going to discuss it together to see if you guys agree or not. All right, so this is how, my friends, the internet companies became more powerful than governments. They were probably not even aware of it themselves yet at this moment. They are aware of it for sure. We all love the internet, but the internet is increasingly becoming a dark place. Websites are made as addictive as possible. Hyper-targeted advertisements influence the behavior of people. And the centralized client-server model, I think, is failing under its own success. Right? It's time for a reboot. If you're more interested in this history, which I briefly explained about here, you can go to the Book of Swarm. The Book of Swarm simply is go to latest.bookofswarm.eth. This is hosted on our gateways. So you go to swarmgateways.net/pcc /latest.bookofswarm.eth, and I will paste it in the chat here. Here it is. I think you guys have it. I'll continue sharing my screen. Definitely recommended read the Book of Swarm, not only about the vision, but also about knowing more about how Swarm works and what are the possibilities of Swarm. It's a big read, but if you have the opportunity and time to read it through, that's great. All right, interactive time. As I said, the picture which I just sketched is just one of the many pictures. And of course, we are here with, I think, about 10, 20 people who are interested in Swarm and hearing about this. So actually, I'll be very interested to hear from you guys, to think about your first experience with the web, how you are using the internet nowadays. Did it change? Was there a difference between your first experience and right now? And then think about the problems which I mentioned in my first slides. What role do you think the internet or the architecture of the internet has played here or is playing here with those problems? And you can already start thinking about it. I will stop sharing my screen. I'll give you access to the website, to the slides, so you can look it back. And we will take 5 minutes for you guys to think about these slides, write them down, and afterwards we're going to take some time to discuss it amongst us. And I pasted the link in the chat. So you can have a look at this first exercise at slide number 38. If you want to see again what were the problems, please look at slide 4, slide 5. And then we take 5 minutes from now, and we'll be back in 5 minutes. Yes, there we are. All right, share my screen. Okay, you guys are here. Are you? All right. Good. So this was the first question. Please please don't be shy. I understand the first one to speak in such a public meeting can be a bit frightening, but if somebody would like to reflect on what you wrote down here, that would be great. You can put up your hand with the feature, and then we can give you the microphone. Yep, okay. I see one hand. Panel hosts, can you give Personium project the microphone?
Hello. Yeah, hi. This is Dixon from Personium project. So I'm kind of an oldie. So my first experience with the web is email, ICQ. I don't know if you heard about it. It's the chat tools, and also Netscape. Like it's not here anymore. So yeah, my first experience. And what I'm using internet for now, it's like basically research for work and watch movie, hobbies, and stay connected with my family and friends. And the biggest change over time, I would say, speed and content. Like the more content they want to have, then they increase the speed. And then I think the problem, last questions. Instead of making our lives better, like it's introducing more problem in the internet. So like we're not doing what we are supposed to have. That's all.
All right. Thank you for sharing that. Okay. Does somebody want to react on that or share your own views? BG, can I have the mic? Panel hosts, yeah. Okay, you can mute BG. I think you can talk now.
So,
yep.
Okay, can you hear me?
Yep, welcome. Thanks for joining.
Hey, it's Brendan. So my first experience with computers was pre-internet actually, and only my dad's computer at work was connected to the net. So it was like a big thing, and you could actually listen. When I finally got internet at home, you could actually listen to the sounds that the modem made. So that was pretty cool. I think like apart from Netscape, was it Netscape Navigator? Like that very early browser. The other brush with the internet that I had was in Windows. It came packaged with a bunch of games. One of them was I think it was Bridge or Poker, one of those card games, and you could actually put in the IP address of someone else running the same Microsoft game, and then you could play over the net. And that was a very interesting concept. You know, you could play with someone just by knowing the IP address.
And Brendan, thanks for sharing that. How did it feel for you, you know, being connected to your dad's computer where you could, I don't know, make a connection with the other side of the world?
It was kind of interesting because I was young enough that I wasn't like supposed to use the phone on myself yet. Like I think probably 8 or something at the time. And we're talking about landline phones. I wasn't allowed to use the landline phone in the house yet. So this was like a covert communications channel almost. So a bit exciting.
All right, and if we reflect on the problems which I outlisted, or what you currently feel about how the internet's developed, do you have an opinion there?
Yeah. I mean, like we all know that the mega corps are using algorithms to kind of dictate what they should show us and whatnot. what not to show us. And I mean, I guess I personally had a theoretical understanding of it for a long time, but I watched this thing on Netflix with the documentary called The Social Dilemma, and one of my favorite scenes is where this guy is kind of like, it's like a low poly model of him, and he's just like hunched over like a zombie, and he's just like rotating left and right, flicking between different screens, and then there's like three guys sort of like auctioning his attention to each other to the highest bidders. Yeah, so like that kind of cemented that for me. I thought it was pretty like like a punch, like a wake up call almost.
Right. Cool. Thanks a lot for sharing this, and Brandon, great you're here. Okay, so I would like to give the microphone to one other participant, which is Goran.
Yeah.
Welcome.
Hello. Thank you. Yeah, so I've been using the internet for a long time. I guess it was in 95-ish that I started using like a very early version of, Netscape and stuff. And it was like Alta Vista, very, very early days. And yeah, that was great. I think also there were some like early IRC rooms that I would attend at that time. I was just a kid back then, but yeah, it was nice. All the information was like open and readily available, and there were no barriers, no paywalls anywhere. And well, today how I use the internet, I've been trying to use the internet less or in a more focused fashion because of these problems that we're discussing, namely that I try to only use it for work or to do research or follow projects such as Swarm and Ethereum, and spend less time online and only do it in a focused way. And well, the change over time has of course been this attention economy, where I find it difficult not to have, like, even when you try to access, if you want to try to access YouTube or something in a way that it's not super tailored to my special interest or the filter bubble that they want to classify me to belong to, it's very difficult. Like, you have to open a new private tab in Brave browser and hope that they don't identify your IP address or geolocate you somehow. And well, I hope with these problems, I hope that it's, of course, it's the economics and the economic incentives are way misaligned when it comes to what we, the human race, needs and wants, and what the corporations needs and wants. And I feel like it's almost like these mega companies like Facebook and Google, they wouldn't even know to pull on the handbrake even if they wanted to, because these companies have become entities of their own even. So yeah, it's need to do something, and I hope Swarm is a part of that.
Yeah, right. Thanks for sharing that. And indeed, I do agree. When we talk about entities like Google or Facebook, and we're angry at them, like, you guys should stop. I think it's not that simple. They also managed by, other people who have interest in them, and it's a very complex situation. All right, thanks for sharing that. I see one more hand. Let's do really quickly, Wojtek, you can join the stage, and you are the last, and then we continue.
All right, sure, thanks. Well, I've got a computer a bit too late compared to, I guess, everyone else. It was early 2000. So a lot of the stuff that you guys mentioned has only been something I've read about. But it's quite unique here in Czech Republic because compared to pretty much everywhere else in the world, we do have a Czech alternative to Google, which is pretty much 50% market share. We do have also some sort of social network, which is not as popular, but as Facebook, but you know, it is quite active. So it's quite interesting here. And the biggest change over time is actually, I do see people leaving this kind of Czech bubble of internet into something a bit more global. More people are going towards Google. Everything is becoming more and more uniform, I would say. And that's interesting to observe.
Right. Do you have something more to add about the problems with it, which you can identify, or was this what you wanted to add?
Well, I mean, the problem that I kind of see the most here is that, and this was mentioned in the social dilemma, is I inherently don't believe that there is malintentions. It's just that the incentives are to maximize your time on the platform and to basically be this attention grabbing system. And I myself am doubting how decentralization will improve this, because every single person always kind of wants to, well, every single organization like this always wants to maximize the attention of the people in the platform. So I just want to kind of understand how this plays, how decentralization can help here, and I hope it can.
All right. Thanks. Well, I've been thinking about this a lot, of course, myself. Whether I believe that a project like Swarm can help with that. I personally think we have a chance, and the main reason being that we offer a different architecture. So like what we analyzed in the previous section is that the client server model has inherently incentives, which in hindsight only could have led to the situation which is currently unfolding. Of course, it's easy to reason in hindsight, but what I do think is that there is no viable alternative available to this architecture. And well, I think that we at least have a chance with a different architecture to balance some of those forces and problems which you mentioned. Okay, good. Thanks everybody for participating. I will start again my presentation and I will continue to the next section. Because of course, it's really easy. Oh yeah, this is the TLDR. The fundamental internet architecture is flawed and got inherent incentives causing mass centralization and the problems which we saw. But I do think that that we should also look at a more positive, constructive position towards these problems, because we can identify the problems, but we need to do more than only identifying something. And the question I can ask myself is, how would the world change positively, but maybe also negatively, if we would consider a different architecture? And just for the record, I'm not saying that this should be the only architecture. I'm saying that it is good to have an alternative and not to have everything on the client server architecture. So let's look at the vision of Swarm projects more in opportunities. And one opportunity, if you would have a network such as Swarm, are truly forkable applications. And what do I mean with that? First of all, open source software, and Swarm is fully open source. You can see here our license, but basically this means that we publish our code. content, in our case on GitHub and other sources as well. And anybody is free to download this software, use it, modify it, even without our permissions, explicit permission. And if you want, you can even make a commercial business on top of the code which we wrote. Right? This is open source software. It allows, wait, did I? Yep, okay, so open source software allows forking, and forking is a term which we use as developers, but it's simply making a copy of the source code and continue the development in its own way. So you see here, and we can stop a pointer, let's say this is the software at one point in time, somebody forks it, there are 2 copies, and this copy develops in one way, and the other copy develops in that way. For example, what we recently did with the Swarm project, we took the source code of a faucet. This faucet was developed initially by who was it? Well, some other blockchain project. They made a faucet on the Gurley network. We also needed the faucet on the Gurley network, but our faucet needed to not only give a handout Gurley testnet tokens, but we also needed to hand out Gurley BCC tokens. It's a token of Swarm. Right, so what we did, we took the source code here, it was still the same. We made our copy, and at that point, there were 2 instances of the same code, but just with a bit of difference, right? So what is so great about that? Well, it allows and it creates actually a huge boot of creativity. Together with Git and other ways to collaborate online, it enforces a lot of collaboration, but free collaboration, right? We could have decided at this point to collaborate with the Gurley team or with the guys who made it initially to add this possibility, but we figured that it's not really in their interest to do so, so we forked it and we really continued our own way. But actually, there are real incentives to make a copy, but not fork it, but collaborate just on one branch, because in that way you make one project bigger and better, and that's great. It's a real great way of collaboration. So it allowed for tinkering and playing with the source code, but also very importantly, commercialization. And actually, if you look at what Amazon is doing, Amazon actually has a lot of their services started as non-for-profit open source initiatives of people just making something they use themselves, and Amazon took it and they commercialized that. Some people think it's bad, and I personally think it's a good thing, because in the end, commercialization is not something bad, because commercialization means that we can put many more resources into making it something perfect and hence more useful. But open source, basically the only option which you have if you want to run an open source application, you must run it on a server which is centralized, right? So here we have the fundamental internet architecture, which we talked about before. The data and application uses some open source code. Open source code is forkable, but if you have this instance of the data and application, it just runs on the physical metal, and this physical metal, the hardware is controlled by one entity, which is the server, and you cannot fork that instance. Just you cannot do that. So you have a dependency of open source software, which is forkable on non-forkable code. 1 second. Maria, could you please close the door? Yep. All right. What if there was no dependency of forkable code on non-forkable data and application instances? That's a question which we can ask ourselves. And as a Swarm project, we believe that with Swarm, this paradigm is within reach. And really, if you think about that, it's great. Well, this was not only a rhetoric question. Actually, I would like you guys to think about this. And without even knowing how Swarm works, put your imagination to use right now and think, what if there was no dependency of forkable code on non-forkable data and application instances? Right? Then again, here I will stop sharing my screen, and I would actually ask Casper not to put on music. It will be a bit easier, I think. I'll stop sharing my screen. This. And this, for everybody who is also looking at the slides, is slide number 55. You can go to it. And you can think for 5 minutes for yourself about this question. And afterwards, we again have some interactive time. Okay, guys, I think that was 5 minutes, so we can start again. So the question was, what if there was no dependency of forkable code on non-forkable data and application instances? So in other words, what if the data and application instances would be forkable? All right. I see Peter put up his hand. I assume that's because you would like to speak about it. Can somebody please give the microphone to Peter? Yep, you're here. You can unmute and talk. Welcome.
Hey, everyone. Thank you. I got two thoughts on this. So first, from the old paradigm, forkable data will give no way to own anything at all. And as a consequence, importance of community will rise a lot more than it is today. And the second thought is more like an intuition. I imagined Ethereum and its data. It's forkable as well. So intuitively, I think forking will be even harder to do because you will have to switch. You will have to convince users to use not just new algorithm, but to alter the whole data, and they will not be able to communicate with an older community.
Yes, I think.
Yeah, and yeah, thanks.
May I continue?
Yeah, and just one last sentence, and I think this thing will let us see something entirely new.
If you can stay on the stage, because I would like to react on that. It's an interesting thought which you just had about actually it will be more forkable. You can very easily fork the data, but what you're saying is that it will be much more difficult to fork the community.
Yeah.
Right. All right. So that's an interesting thought, because basically right now, if you want to fork the community, you will have to put in efforts to actually make your data instance better than what it used to be. It was actually the same thing what we saw with open source code. So if you want to fork a project and want this project to become more successful than the main one, you needed the codes to be significantly better, because otherwise you would never convince somebody. And the same is basically here. So in the old paradigm, basically there is a dictator, and he decides, he or she, or the owner decides whatever he wants to do with the instance. But in a new paradigm, you would need to fork it. But if you want to also take over the community, you actually need to have a better application.
Yeah.
Yeah. Okay, that's interesting, and thanks for sharing. Indeed, what you say is true. Ethereum is also an application which has forkable data. I didn't think about it in that way, but you're correct. Okay, thanks for sharing this thought with us. I see Rodrigo put up the hand. Yeah, Peter, if you can mute. Yeah, thanks, and Rodrigo, thanks for joining. Yes, I hear you.
Yes. Hi. Well, I have an opinion about this topic actually, because I guess this model or this dependence exists because of consistency and performance of the system that required. And this is actually a very difficult topic, because for this, many of research of distributed systems try to solve this, and how you can still ensure the consistency when your data is not centralized more in some data center. And this is actually the interesting challenge that I'm interested in Swarm, like, or any distributed centralized storage solution, because this is a point that you can, as another participant mentioned, you can ensure that users will take control of their data, and this will create a new kind of market that also can help with the privacy problems and this stuff. So this is actually, I guess, the high point of the research that we are right now, that we never had before, and what is the so many challenges that we can, try to explore to remove this dependence, but that so far for me that exists to keep the consistency of the data when you need it, and to keep also the performance of the system overall. So
yeah, thanks for sharing that, and I agree. Also, I want to highlight here is that the reason I'm asking this question is that because I'm genuinely interested in what you guys think. What's we can identify is that Swarm does make such an architecture where this is possible for applications, but really the impact of that is to be seen, and this is why it's so important to talk with you guys to talk about this, so we can identify where are the biggest use cases and what we have to think about it. Okay, I want to ask something to panelists or people who have been involved with Swarm more often, because there is actually one video of Dani Nagy, who is talking in Madrid about forkable social media applications. I don't have time to search it right now. It's somewhere in YouTube. But if somebody has the time to look up this video and share it with everybody, that would be great, because Dani Nagy is one of the founders of Swarm and actually has a very interesting video where he talks about a social media application which is forkable. The community is forkable. All right. Let's go to the next question, because this is also really interesting, and let's do a bit shorter here. We're not giving you 5 minutes, but maybe 2 minutes to think about it. The question is, what type of applications would flourish on forkable data, and actually you should say forkable community. I think that's more what it actually is. So what type of application would flourish being a type of application where the community can be forked? And what type of applications won't? You can think about it, and then we will talk about it again together. And we do 2 minutes right now. All right, I think that was about 2 minutes. 2 minutes, way too short to think about this seriously. So I invite everybody after the workshop, if you think these questions are interesting and you want to think about them more, and you want to share your thoughts with the Swarm team, or to just think about this, please do reach out to us, because these are the type of questions which we think about. I wouldn't say on a daily basis, but pretty often, and we definitely like to talk about this. So if you want to think about this more, reach out to us. For now, we are up, and I need to stop my share because I would, of course, like to give somebody the microphone. Peter and Rodrigo, you guys were already here. Let's see if somebody else wants to chat, and otherwise all right, Peter, you are still a panelist, so go ahead.
Thanks. So I think, and what I would like to see is a more decentralized chats, so that one database for multiple clients, not a fork actually, but just a guaranteed access to chats database. That would be awesome. Then games. I'm not a fan of games, but I think games could benefit a lot from forking data. And as I'm dealing with decentralized identity, I think I think of that as well. So decentralized identity and everything related to personal information, if this data could be forkable and accessed in reliable and secure way, that would be awesome too. So these are my three thoughts, examples.
Cool. Thanks. So about games, maybe a little anecdote. Did you know that actually Vitalik Buterin is somewhere in one forum, I don't know anymore, but he wrote that actually one of his reasons that he was so interested in Bitcoin at that time is because he was adamant World of Warcraft player. And at one point he got so fed up with Blizzard pushing an upgrade, and he actually didn't want this upgrade. And he was so fed up with that, and he saw actually that blockchain. So indeed, that portable data type of way would be a way how you could counteract such, I would say, dictatorship. So that's that little anecdote. Indeed, why games? Yeah. Okay. Cool. Thanks for sharing that. We continue because we already 1 hour in the workshop, and we have 1 hour left, and there is like a ton of things to do. So if you could mute yourself, Peter, then I will continue and share my screen. Let's see. Yep. Here we are. So yeah, my personal thought on this is everything I've mentioned, but how I like to think about this is that I still think that the centralized server architecture is valuable. For example, for storing personal data, or for very privacy sensitive, or things where it's important that application holder has a bit more control. But I think that anything that involves a community, be it social networks or games or anything where the community, so not the owner, makes the value, I think these are the type of applications which we have to look into that will be best hosted on such things. Also, because one interesting thing, this is more of a answer to this, if you have applications with forkable data, what could happen, for example, and this is unthinkable nowadays, but what could happen is you take data of your social network, and you're not only, and let's say company A starts an application, has the data on a network like Swarm, and our company B takes this data and is like, okay, I can make a different application on top of this. So let's say we already have the social network, and it just makes a game using exactly the same data. So that's interesting, because now you can interact with this data from 2 application instances, and maybe what you're doing on the social network influences your stats on the game, right? So that's also a new paradigm shift, and it opens so many opportunities. All right. Well, Swarm fundamentals, and we haven't even talked about Swarm up until this point. So right now really is the time to start talking about this. And I will very briefly talk about Swarm in a nutshell, and then I'm going to give the microphone to Janos, and he will, you can start using the Swarm nodes in half an hour, I would say. All right, so Swarm in a nutshell. I like to think about Swarm as a decentralized hard disk or hard drive, which is living everywhere around the world. Everybody can access it, everybody can write to it, everybody can read to it. Nobody owns this hard drive. We are all owning it as a Swarm, right? Nodes, and this, by the way, is how I'm explaining Swarm to my friends. If they never heard about Swarm before and they are also not tech savvy, then I like to explain Swarm like this. So nodes are free to join and leave the network. So anybody can become a store, anybody can leave a king if he doesn't like it anymore, and anybody can read, really. Each node, and a node, by the way, is a computer that is part of this network that's running the Swarm protocol. So each node in the network is responsible for storing data pieces in a certain partition of the disk. So the disk is this hard drive, right? So basically think about a real hard drive. A hard drive has a lot of partitions, and each partition, some data is stored. If I just take with a microscope, maybe on one partition of a hard disk, I will probably be able to see the physical bits there, zeros and one being switched on and off. But if I just see that, I cannot make sense of what is there. Well, the same for a node in the Swarm network. A node in the Swarm network stores chunks, and chunks on their own are 4 kilobytes big. They don't mean anything. It's just the collection of chunks that make up files. But for the nodes themselves, they really cannot say, I want to censor, I don't know, the anthem of the Netherlands. Because those nodes, they store chunks, and maybe some of those chunks are part of the anthem of the Netherlands. They probably don't even know this. And even if they knew, they can censor themselves to not serve those chunks anymore. But there's always duplication. So yeah, that really a node in the network doesn't have any power, also doesn't have any say about which chunks he's storing and which ones not. Yeah, so nodes are not opinionated about what is stored. If they come online, chunks will be synced to them based on the partition they join. So nodes have an address. Based on this address, certain chunks will be sent to his local store. The network, and this is actually the protocols of Swarm, they take automatically care of syncing when nodes join or leave the network. About redundancy, so data is always duplicated around, and we also use erasure coding, not now, but actually people working on it already, and fault tolerance. Next one. All right. So what can I do with it? Well, basically you can write to it and you can read from it, just like a normal hard drive. The physical hard drive, that's basically everything you can do. Maybe you can read some stats or something like this, but this is what you can do with it. It's just the layers on top, like the file system or I don't know, a server that actually add the functionality on top of this basic read write. But reading and writing are super powerful, so that's you can do it with Swarm as well. So write, what happens? How do I write a chunk or a file to the Swarm? So the first thing, if I have a file, what I do on my own computer, I'm going to chunk it. I'm going to piece it up to a certain algorithm in these 4 kilobytes chunks. Each chunk has an address. I send those chunks to the network via my own node, and I don't have the chunks anymore myself, and they are somewhere in the network at that point. Reading is the opposite of that. I'm reading a file. I reference it by the Swarm address. I'm going to figure out which chunks are under that file. I'm going to request those chunks from various spaces in the network. And on my own computer, those chunks are being pieced together and presented to me as a file or a website or a message. Right? But why would any node want to contribute their storage space and bandwidth to the network? And I would say this is one of the most important things also from Swarm, because it's something public, right? It's public infrastructure. Well, basically it's incentives. So this hard drive being there in the public, of course, needs to be maintained, and somebody needs to have an incentive to run the node and put their own hard drive storage at the use of the network. So Swarm has various clever incentives, basically to do economic transfer of value from the people who want to use the network to the people who are contributing to the network. we're having two types of incentives. One is bandwidth incentives. So if you are actually requesting something or pushing something to the network right now, and the other one is storage incentives. Storage incentives if you want to utilize the storage space in the network. That is Swarm in a nutshell.